Hi, this is Leetcode question number 460, LFU Cache. Design and implement a data structure for a least frequently used cache. Implement the LFU Cache class. LFU Cache constructor take capacity. Initialize the object with the capacity of the data structure. Integer get function takes key. Gets the value of the key if the key exists in the cache, otherwise return -1. Function put takes key and value, update the value of the key if present, or insert the key if not already present. When the cache reaches its capacity, it should invalidate and remove the least frequently used key before inserting a new item. For this problem, when there is a tie, two or more keys with the same frequency, the least recently used key would be invalidated. To determine the least frequently used key, a use counter is maintained for each key in the cache. The key with the smallest use counter is the least frequently used key. When a key is first inserted into the cache, its use counter is set to 1 due to the put operation. The use counter for the key in the cache is incremented. Either a get or put operation is called on it. The function get and put must each run in big O of 1, average time complexity. Here we have cache with capacity equal 2 in this example. So capacity equal 2, and let's say size represent how many key already inserted, and initially it's 0. Then we have use counter vector counter. It's a table that we will use to know how many times the key accessed. So we have key 0, 1, 2, 3, 4, and initially the count for each is 0 because none of the keys accessed yet. Then we have values table to store the key value of key 0, 1, 2, 3, 4, and the values are initially -1. That means these keys are not filled yet. Now let's take the first call, put 1, 1. Now the size is 0, which is less than the capacity. That means we can insert this 1, 1, and the key 1 is not inserted yet because the value is -1 and the count is 0. So now we can insert it and set the value to 1, and the counter will be increased to 1, and up to now we have 1 key inserted. Then we have this call put 2, 2. Again, the size is less than the capacity, and key 2 is not inserted yet because its value is -1 and the counter is 0. So we can now insert the key 2 and assign it the value 2 and increase the counter to 1, because here when a key is first inserted into the cache, its use counter is set to 1 due to the put operation. And until now 2 keys are inserted, key 1 and 2. Then we have this call get 1. Now we should return what is the value of the key 1. The value is 1 so we print 1 in the output, and since we call get operation, the counter will be increased by 1, so the value is 2. Then we have put 3. Now the size equal the capacity, and that means the cache is full, so we need to put we need to invalidate one of the keys, and the least frequently used, which means the key that has the list count, will be invalidated. Here we have key 1 with value of count 2 and 2 with value 1, so the least frequently used is key 2, so we will invalidate this key, and so we reset the counter to 0 and the value to -1. Then we insert 3, so 3, take the value 3 and we increase the counter for 3 to 1. Then next we have get 2. What is the value for 2? It's -1, so we just print -1 in the output. Next we call get 3. What is the value for 3? It's a 3, so we need to print 3 in the output, and because we call get operation, we need to increase the counter for the key by 1, so it becomes 2. Then we have put 4. The cache is full, so we need to invalidate the least frequently used. Key 1 has count 2, key 3 has count 2. Now we need to take the least recently used, and the least recently used is key 1, because the last key we accessed is 3, and so 1 is the least recently used, so we need to invalidate 1, and to do that we set the counter to 0 and its value to -1, and we need now to insert 4, so key 4 takes the value 4 and the counter is 1. Then we have get 1. What is the value for 1? It's -1, so we print -1. Then we have get 3. What is the value for 3? It's 3, so we print 3. Then we have get 4. What is the value? And remember, when we return for 3, we return 3 and we increase the counter, so this becomes 3. For 4, the value is 4, so we print 4 and we increase the counter by 1. Now, how can we solve this problem? We need some variables in our class. Capacity represent the capacity of the cache, as we saw in the example it's 2. LFU is the least frequently used key, and this key will be invalidated if the cache is full. Then we have these two tables, use counter and values, and we saw them already in the example, and these vectors are the size of this vector initially set to 10 to the power 1, which is the maximum of the values or the max of the key we can get, and initially the count for every key is 0 and the value is -1. Then this is size, size represents how many keys already inserted. Now we have these two dictionary. Count keys map represents a map where the key is the count in a count table or user count table. So this is the count, and the values are, value is linked list or double linked list, and that has the keys. So all the keys that have the value of this count are assigned to this linked list, and this is double linked list, so that we can easily access the end and the beginning and insert and delete with time complexity of 1. This dictionary key iterator map will map the key to the pointer in the set. For example, for this key, let's say this is key 1, and we have this iterator or pointer. So the value 1, which is the key, will hold this value, iterator value, and so we can access directly in the linked list, or we know where is the key 1 in the linked list, and we don't need to search all the linked list, so we can directly access that pointer. Alright, let's take the example again. So the capacity is 2, so this variable capacity will be initialized to 2 here. Then we have put 1 1. Now function put 1 1, we check if capacity equals 0, and that means this cache cannot accept any key because the capacity is 0. In this case we don't need to do anything, we just return. Now here values of the key, if the value of the key not equal -1, so initially we have capacity equal 1 equal 2, and we have size equal 0, and we have this vector user or use count, and we set its initially filled of zeros, 1 2 3 4, and we have values here, 1 2 3 4, and initially these values are -1. Then we have the dictionary count key map, count key map, and it's initially empty. Then we have the dictionary use counter, or sorry, we have the dictionary count this key iterator map, key iterator map, which initially is empty. Now we said we need to put 1 1 into the cache is value of the key equal not equal -1. The value of key 1 is -1, so this condition does not apply. We call it this else, and what we do, use counter of the key +1. So use counter of the key is 1. Values of the key equal value, so this is 1. Now we need to check if size less than capacity. Remember, we have another variable LFU initially -1. Now size is less than capacity, which is 2. Then we need to go to this if statement. First we increase the size, so the size is 1. Then we need to check if LFU equal -1. It is -1. Then this key will be the least frequently used, so we assign the key, which is 1, to this variable. Then use counter of key equal 1. This is duplicate, you don't need it because you assign it here. Here we have count keys map of 1 to push back of the key, and this means, so here we have this count 1 for key 1, and that means for this dictionary, the count 1, we will add the key 1 to the end of the linked list. So the linked list is 1. This is the key and this is the count. And also, let's say this is iterator 1, which is pointer to this linked list. So here for 1 we will assign iterator 1. That's all. Next we have put 2 2. Now again, is the value of 2 not equal -1? Wrong, so we go to the else. Now use counter of the key equal 1. So this means that this is a new key. Use counter is for 2 is 1, and the value of the key is equal the value, so 2 is 2. Then is the size equal the less than the capacity? Here we have the size 1, so yes, it's equal than the capacity. Then we need to update it to 2, because here we have size ++. Then is least frequently used -1? No, because the variable is 1. Then we go to this if statement and check if the count keys map of 1 dot empty count keys 1. It's not empty, so we don't update the key, we only update it if it's empty. And that means, because this new, the 2 has the value 1 and this has 1, this one will be invalidated. This one will be invalidated because it's least recently used. That's it for this call. Now we have count of key maps of 1 dot push backlal key, and that means we need to push to the end of the linked list the value for the key 2, and key iterator map of key equal previous of n, which is the value we just or the iterator we just added. So let's say this is iterator 2. So in this dictionary we'll have 2 equal pointer 2. Now next we have this call, which is get 1. Now we need to check if the values of the key is not equal -1. In that case this key is not assigned value yet, and we return -1. So get 1 is not -1, so we come here, count of the keys maps of use counter of key dot erase key iterator map of key, and this is because the get operation will increase the count, this use count, by 1. So 1 will be increased, become 2. Then we need to remove this 1 from this linked list, and this is what we are doing here. So the key 1 is mapped to it1 or iterator 1, which is this one, and we need to remove this, and the linked list will have count 1 with the key 2, and later on we will assign the value 2 or the key 2. Now we need to check if least frequently used is the key itself. The least frequently used is 1, and the get is for operation 1. So this condition apply. Now we need to check if not count of keys of counter dot empty user counter of key. This is user counter of key 1 is 1, and we need to check if this linked list is empty, and the answer is no. In that case, this one, because it has value 1 or the count 1, it will be the new least frequently used. So this one we will assign it to least frequently used. So we have 2. Now we apply this if condition. Now use counter of the key, we add 1, we have the key 1, and so we increased by 1, so we have 2. Count of key map. Now this value 2, we need to insert the key corresponding to it, which is 1. So this linked list will have this key 1, and this is iterator 1, which is pointer to this node. So here also key of iterator map of the key equal this one, we insert it here. So this one will point to this node. It's the same name here, but it's different pointer. So it1 will point here now in this linked list, and at the end we return values of key. Values of 1 is 1, so just print 1. Next call is put 3. Now again in the put function we need to check if values of key not equal -1. So we are assigning 3, and the 3 is -1. So again we need to go to this else. Now use counter of the key equal 1. So this is 1. The value is of the key is the value, so this becomes 3. Now is size is less than capacity? No, because the size is 2, which equal the capacity, and the cache is full. Now first of all we need to invalidate the key 2. This is why we set values of least frequently used to -1. So this becomes -1, and also we need to remove it from the linked list, and this is what we are doing here. Use of counter of LFU is for 2. The use counter is 1, and 1 is here, and so we can find this 2, and we remove it. So this linked list for key 1 is empty now, and use counter of the invalidated key, of course it's 0, so we invalidated this key 2, so the value of 2 is 0, or the count will be 0. Now after that we need a new key, or a new least frequently key. If the count of the key of map is empty, so this key has no value, it's empty, and that means the new inserted key will take the value, which is 3, because this one will have this key 3, or the key 3 that we are going to insert it now later on. So LFU will equal to key, and now we have count keys of map of 1, push the key, and this is what we said. We need to insert the key 3 into this count 1. This is the iterator, and also key iterator map of key equal iterator 3. This is just the pointer where it is in the linked list. We are done with this put operation, and as we said, now our LFU is 3. Then we have get to if the value of the key 2, the value is -1. If the value equal -1, return -1, and as you can see here, the last value was -1, so we just print -1. Then we have this query, get to 3. Is the value of 3 -1? No, it's a 3. In that case we need to erase we need to remove the node from the linked list, so the key 3 will remove it from linked list, and 1 becomes empty. Then we need to check if this 3 is the key, or it's the LFU, and the answer is yes, because we have 3. and in that case we need to check if the count of key of user count dot empty. So is this list empty? The answer is yes. It's so we come here because this check if it's not empty. Now if count of keys plus 1, so we have this user count of 3 is 1. 1 plus 1 equal 2 because we are going to insert 3. Now 2, is it have any value? The answer is yes. We have this node, and so LFU will take this value. So instead of 3 we'll have LFU equal 1. Then we update the counter for the key. The key comes 2, and we assign it to the linked list. So here we have the count 2, so we assign it here to the end. So count 2 contains 1 and 3, and of course we update the pointer. This is iterator 3, and we retain values of key. Values of 3 is 3, so the answer printed is 3. Next call is put 4. Now 4 equal -1, so we got to this else statement. Use count of L4 equal 1 because we are inserting it. So this is 1 and the value is 4. If size less than capacity, no, we come to this else. Value, we need to invalidate the LFU. Current LFU is 1, so we need to invalidate it. First of all, we need to put the value to -1, so the value is so this is 4, and the value of the key 1 comes -1. Then we need to remove this one from the linked list, so we have it here. So we remove this one and the linked list becomes 4.2 becomes only 3, and use counter of least frequently used is 0. So for 1 it becomes 0. Then we need to check if count of keys of map of 1 dot empty to see if we can assign. So if it's not empty, then that means we can take the new LFU from there. If it's empty, we need to go to this line. So 1 here, it's empty since all of these are removed, and that means the LFU is equal the key, because we just inserted the key 4, and so LFU is 4. Now count of keys of 1 push the key, So here we assigned new node, which is 4, and the count for 4 is 1. Then we have key iterator. We need this pointer to this node 4. So node 4 has iterator 4, and that's it for this call. Now get 1. Again, value of key, is it -1? Yes. So for value 1, because we just invalidated it, so value we print -1, which is this one. The next call is get 3. So the value of 3 is 3, so it's not -1, and that means first of all we need to update the linked list, because the counter for 3 will increase by 1, so we need first to remove it from this 2. 2 is empty now, and we are doing this in this line. Then we need to check if LFU equal key. So our query is the key is 3, and the LFU equal to 4. So it's LFU is not equal to key, and that means we need to keep it as is. Then we need to update use counter of key. The key is, again, it's 3, so counter of 3 is 3, and we need to insert this count 3, the key, so 3 will have the node 3, and of course iterator 3, which point to this node, and we return value of the key, which is 3, and here we print 3. Next we have the last query, which is get 4. Now 4 is not -1, and we need to check if 4 equal to the key, and that's true. 4 equal to the key. Then we need to check if the count of user count of key, count of 4 is 1. So 1. Does 1 have any value? So as we said here, count of key we erase it first. So we remove the value 4 from the dictionary, and here if the count of key dot empty, which is this one, it's empty, so we'll go to this. Else if the count +1 dot empty, so we have count for 1, so we need to check for 2 if it's empty. 2 is empty also, and that means we are not going to do anything with this is frequently used. So we update the counter, use counter of the key by 1, so 4, this one becomes 2, and we need to assign it to the dictionary. So here we have for the count 2, we have the new node 4. We move it from here to here, and because this is empty and this is empty, so that least frequently used value will remains the same, and the end we need to return the value of 4, which is 4. And the time complexity of all of these operations is big O of 1.